Hi everybody! So, now that we've completed the concepts behind excess and limiting reagents, we now move on to the next part of mole applications in quantitative chemistry, water of crystallization, as you see I've written here, okay? Don't mind the pictures. Anyway, so for this part I just want you to pay more special attention because this is likely something that you probably wouldn't have covered in full detail in IGCSE. So, obviously, you might have heard of the term water crystallization IGCSE, but it's mostly the qualitative side of it. Like you're describing a procedure of how to form hydrated salt crystals out of a saturated solution. But in IB, you have to be able to apply mathematics to the calculations within water crystallization. Yes, and I know that the last thing you probably want to do is more mathematics, but we still got to go through it, okay? So, but the good news here in IB is that there's not many ways in which that they can ask you about water crystallization. So, as you can see, I put up two questions here, this question and this question over here. So these two questions here are the main two ways that IB would ask you about water crystallization. If the question is any more different, then it usually should just involve taking the concepts of how to answer these questions and applying them into that particular question. Okay, so let's get started on the first one here. So this question is likely something that you might find in the current IGCSE syllabus because they actually just changed it this year. So yeah, this is the kind of question that would appear in probably next year's IGCSE exam. I'm not sure about this year because actually maybe I should ask my sister because she was taking the IGCSE syllabus this year. So yeah. Anyway, let's get to the question. So, a hydrated carbonate has a relative formula mass of 286. Oh, one more thing. I forgot to mention this, but whenever you're talking about the relative atomic mass of a compound, we call it relative formula mass, okay? So, if a question just comes up to you and just says relative formula mass, then you would know it's the relative atomic mass of a compound. I mean, when you come to answering the question, you don't necessarily have to use the term relative formula mass. You could just stick with relative atomic mass, but if you see this in the exam, then just don't get confused. It's the same as relative atomic mass, but it's for a compound. Okay? Anyway, so where X represents a metal cation. So as you can see, we have a carbonate here, metal cation with a carbonate ion, and it's hydrated with 10 moles of water. Notice the states, okay, because it's solid crystals, right? So now it's asking us to identify what X is. So without doing any calculations, we can immediately deduce a few things. So if you remember from IGCSE, the carbonate ion, okay, CO3, has a 2 minus charge, so 2 minus right there. So that's the carbonate ion. Now, as for the metal cation, that means the total charge of two X's, because X2, so X2 needs to have a charge of 2 plus, needs to have a total charge of 2 plus, and thus meaning that every X cation has a charge of 1 plus, so you'd have a cation like this. So if it's a 1 plus charge, then if we look in the periodic table here, then we know that X would lie in group 1 of the periodic table, which means that X is an alkali metal. It could be lithium, potassium, sodium, cesium, rubidium, all the any one of the alkali metals. We just need to find out which one it is. Okay, so now that we know that it's lying in the alkali metal section, we can now use calculations to determine the actual relative atomic mass of X. How do we do this? So obviously we can set up an equation first because relative formula mass, okay, equals to 286, which equals to 2x to the relative atomic mass of X, plus 1 carbon, so 12.01, and then plus, I'm just going to do this all at once, so 3 oxygens, 10 oxygens here, so 13 times 16.00, okay, and then plus, I'm just going to do some of the math directly, so it's 20, because 10 times 2, 20 times 1.01, that's relative atomic mass of hydrogen, so 1.01 times 20, that's 20.2, okay? So, now we just make the X a subject, 2x equals to 286, minus, just going to bracket here, 12.01 plus 13 times 16.00 plus 20.2, okay? So after constructing this equation, all we need to do is just to solve for X. So X in this case, if we just plug into the calculator, would be equal to, as I've written here, 22.90 correct to 2 decimal figures, okay? Two decimal points. So one thing I want you to know, the calculated value of x in these kinds of questions will not always fit what's seen on the periodic table, so you can't always expect it to be precise every time. So, but the good news here is that we know that x is an alkaline metal, and we also know the relative atomic mass is somewhere close to 22.9, and thus if we look at the periodic table, we would see that sodium has a relative atomic mass of 22.99, the closest to X, because it's an alkaline metal, and also it's close to the relative atomic mass here, okay? Which means X is sodium. Sodium. Na. Okay? So that's basically how you would do this question over here. Alright guys, I'm back in the change of clothes actually, because apparently as I was recording halfway my phone died, so the phone didn't catch the last half of me explaining this question, so here I am just going to record it again just for you guys, okay? Anyway, let's get into it. So this next question is more of something that you would see in the IB syllabus when they talk about water crystallization. It's where it's more purely based around applying the mole concept in more innovative ways instead of just the standard approach that you would normally see. Okay. So anyway, so I'm just going to go through the question. So 11.25 grams of hydrated copper sulfate. Now the hydrated. Oh, and by the way, just a special treat for you guys. Actually, if you see here this dish, see these blue crystals? These blue crystals here are actually hydrated copper sulfates. So yeah, I've been growing them for about a week now. They look quite pretty actually. So at the moment you might be wondering why these are blue in color. So rest assured, you actually need to know this in IB chemistry, but just not at the moment right now, because we'll kind of come to that in a future video. But I just wanted to point this out because when you get a question that is similar to this, you would usually get a supplementary question that asks about why these crystals are blue. Why aren't they green? Why aren't they orange? Why aren't they purple? Why are they only blue? Okay, so just keep that in mind as we're going through this question. Okay, so and also one more thing, because hydrated copper sulfate is one of those compounds that are really popular with IB examiners. So if you see this kind of question in the exam board, don't be that surprised by it. Okay, so anyway, here we go. So we've talked about the mass of hydrated copper sulfate. So it is heated until all of the copper sulfate is anhydrous. Okay, so if you remember back in IGCSE, you would recall that anhydrous copper sulfate is a white solid. Okay, so hydrated copper sulfate is blue in color, so when you strongly heated it, you've evaporated the water out. Notice all the water, there's water in the hydrated copper sulfate, but in here all the water is gone, so it's anhydrous. As it becomes anhydrous, it slowly becomes white. Okay, so given that the final mass of the compound is 7.19 grams, find the value of X. Okay, whenever it comes to water of crystallization, you can always assume that the mass lost of heating a hydrated salt compound is always due to the loss in the mass of water. Okay, so, or more specifically, the evaporation of water. So, H2O, we put the states on, evaporated. So that's going to be equal to 11.25 grams minus 7.19 grams, because assuming that all the mass disappeared is in the form of the evaporated water. So the mass of water evaporated will be 4.06 grams. Okay, so now here, since we know the molar mass of water, and we also know the mass of the given substance of water where it has been evaporated, we can use this relationship here. Okay, if you remember back in our first video, number of moles, small m, the molar mass. Okay, this relationship. So we need to find n. So n is equal to 4.06 grams, okay, over 18.02 grams per mole. This is the relative formula mass of water, okay? So I'm not bothered to write out the calculation here. You could just do the calculation yourself in a calculator just to be sure about that. So if we just look here, 4.06 grams divided by 18.02 grams per mole would be equal to 0.225 moles, okay? So that's the amount of water that has evaporated from the compound upon heating. Okay, so that's the first thing we need to know. Now the second thing we need to know is the amount of copper sulfate that is in the salt. Okay, and more specifically just the salt itself, excluding the water, or in other words, the anhydrous version of it. Okay? So, given that we've already assumed that the loss in mass upon heating is due to 100% of water evaporation, then that means there is likely not going to be any copper sulfate that is lost in the process. And theoretically, there shouldn't be. So in the sense that we can say that the mass of copper sulfate that is left in the dish, or initially in the salt, is actually just 7.19 grams. Okay? So once again, since we know the relative formula mass, and we also know the mass of the given substance, then we could use this relationship again to calculate the number of moles. So N equals to 7.19 grams, little m, over the relative atomic mass of copper sulfate, the anhydrous form of it. So I've just done this calculation in my calculator again, so it's 159.61 grams per mole. So if I divide little m by the molar mass, then thus we would have, as I calculated here somewhere, here, okay, 0.0, make that point a little more obvious, 450 moles. Okay, so we calculate so this is the amount of copper sulfate that has been left in the dish upon heating. So now that we calculated the amount of water that has evaporated, and also the amount of copper sulfate in the salt, then how do we solve for x in the end? So one of the ways we can think of this is if we just look at this formula of the hydrated salt, we can see this is a mole ratio almost, okay? So I'm not sure if you get my analogy here, so let me just explain it here, okay? So for every 1 mole of copper sulfate there is, it is binded to x many moles of water, okay? So in a sense, it's 1 to x. So we go 1 over x would equal to, so 1 over x in this sense is the ratio between the amount of moles of copper sulfate to the amount of water evaporated, okay? So 1 over x thus equals to 0.0450 moles, the amount of copper sulfate in the salt, and over 0.225 moles, okay? The amount of water that has evaporated upon heating. So we just calculate the value of x, make x a subject, thus we will find that x is approximately equivalent to 5.00, okay? So x is thus equal to 5. And therefore, the overall formula of this would be CuSO4 dot means the water crystallization, 5, wait, let me just write the 5 better, 5H2O, solid. Okay, so this is thus the overall formula, CuSO4 5H2O. So that is the method that is most ideal for approaching this kind of question. So that's pretty much everything you need to know about water crystallization in terms of how you approach the questions. Now because the approaching method of those questions is relatively similar, I'm not going to go into any more questions now. So what I will do instead is I've posted an exercise in the description down below, so you can just click into it and just try and do it yourself. If you want any feedback on it, then just feel free to drop me a comment or send me an email and I'll just review the work for you, okay? So in the next video, we're going to be covering empirical formula deduction. So you've probably heard of empirical formula deduction in GCSE, but in the IB, we're going to learn a new way to calculate the empirical formula of a given compound and how to extend that formula into deducing a formula's structural formula and also its relative formula mass. Okay, so see you next time.